This is my second video lesson for Unit 7. In this lesson, we'll be describing heat flow and phase change. Go to page 6 in the class packet. Motivation: how does heat flow and why? Take a moment to watch a TED video about heat flow. The link to the video will be under the description. Once you watch the video, resume this one. Learning target. At the end of the lesson, I will be able to describe heat flow and phase changes and convert between Celsius and Kelvin. Homework B number 2, which will be a Junipod based off this lesson. Here we have a cartoon. How is heat flowing in this cartoon? The guy is holding a hot cup, so you can see that the heat is flowing from the cup to the person. How about if you're holding an ice cube? The heat is flowing from your hand to the ice cube. That's why the ice cube is melting. Heat flows from a warmer substance to a cooler substance until both are equal in temperature. So as you can see from this example, the heat from the flame is heating up the cooler air molecules. Let's say we have two objects. The red object is hotter than the blue object. If they were to touch, heat will flow from the red object to the blue object because the red object is hotter than the blue object. As heat flows, eventually both objects will reach the same temperature. This is known as thermal equilibrium. That's when the objects in contact have the same constant temperature. Heat will no longer flow at thermal equilibrium. Here's a GIF showing heat flow and thermal equilibrium. Initially, both objects were at different temperature, but eventually, after heat flow, they will reach thermal equilibrium in which heat no longer flows. Learning check number 1. A person with a body temperature of 37 degrees Celsius holds an ice cube with a temperature of 0 degrees Celsius in a room where the air temperature is 20 degrees Celsius. The direction of the heat flow is what? Pause the video and resume once completed. Heat flows from hot to cold, from a higher temperature to a lower temperature. So therefore, the heat will flow from the person to the ice cube and the air, and from the air to the ice cube. Answer is choice 2. Let's compare the properties of solid, liquid, and gas. The first property is the strength of intramolecular force, and solid is very strong, liquid is strong, and gas is very weak. For the distance between the particles in the solid, they're very close. For liquid is close, and for gas is far. Keep in mind, liquid is not the midpoint of solid and gas. If you look at the particle distance in the liquid, it's much closer to the particle distance of a solid than it is to a gas. For kinetic energy, you expect gas to have the highest average kinetic energy because it's moving the fastest. So for solid, it is slow, liquid is medium, and gas is fast. And here are the particle diagrams of solid, liquid, and gas. Why does a substance change phases? When you add or remove energy. Here's a nice diagram showing the phase changes and the energy. As you go up, you're absorbing energy. As you go down, you're releasing energy. So melting and fusion are endothermic. Freezing is exothermic. Boiling and vaporization is endothermic. Condensation is exothermic. Sublimation is endothermic. Deposition is exothermic. Ionization is endothermic. And deionization is exothermic. Would temperature change during a phase change? The answer is no, because you're breaking the intramolecular forces. We'll discuss this in more detail later on in the unit. Learning check number 2. Which change results in a release of energy? Pause the video and resume once completed. So which of these is an exothermic process? That will be choice 4, condensation of H2O. Learning check number 3. The phase change represented by the equation I2 solid to I2 gas is called what? Pause the video and resume once completed. Since you're going from a solid to a gas, this is sublimation. Here's a GIF showing the sublimation of iodine. So you can see that the solid is becoming a vapor. Here's a GIF showing the sublimation of solid carbon dioxide. Here's another diagram showing the phase changes. Keep in mind, melting can also be known as fusion, and from liquid to gas can be boiling or evaporation. Now I want you to read an article on page 7 about the Kelvin scale. Pause the video and resume once you read it. So question 1, why do we use the Kelvin scale in science? It is because the Kelvin scale is the absolute scale. It means there's no negative numbers, and 0 Kelvin means no kinetic energy. Question 2. If the temperature changed from 10 degrees Celsius to 20 degrees Celsius, did the temperature double? That means did it get twice as hot? How about 10 Kelvin to 20 Kelvin? The temperature changed from 10 degrees Celsius to 20 degrees Celsius. The temperature did not double because it basically went from 283 Kelvin to 293 Kelvin. It did not get twice as hot, and the molecules did not move twice as fast. However, from 10 Kelvin to 20 Kelvin, the temperature did double because the average kinetic energy doubled. Learning check number 4. Which Kelvin temperature is equal to minus 73 Celsius? Pause the video and resume once completed. You have to use the equation on table T in your reference table. Kelvin is equal to Celsius plus 273. If you do that, the answer is 200 Kelvin. Learning check number 5. At which temperature does an aqueous solution of LiCl have the highest average kinetic energy? Pause the video and resume once completed. Since you're given 2 units of temperature, you have to convert it to the same unit. Once you do that, the one with the highest temperature is 200 degrees Celsius. Therefore, it has the highest average kinetic energy. This concludes the video lesson for today. Remember to do the Junior Pod homework.